Hello, I'm Edward Tarte, math teacher. This is another in a series of solution videos for some of my math challenges. The math challenge for this solution video is my Campers and Bottle challenge. And here is how I presented that challenge in the original video. On a Saturday afternoon at 1:35, a couple of campers set out from their camp paddling up the river in a canoe. They paddled at a rate which in still water would have been 4 miles per hour, and they maintained this paddling throughout this problem. But they were paddling upstream against a current of 1.5 miles per hour, and that current, of course, slowed them. At 3:11 p.m., they came abreast of a corked bottle floating in the river. They continued on their way, and the time came when they turned around and headed back toward their camp. And when they got to their camp, they drew abreast of the bottle. That is, the bottle reached the camp at the same time that they returned to it. And my question is, how far from their camp did they paddle up the river? Here is my solution. They left camp at 1:35 p.m. and came alongside the corked bottle at 3:11 p.m. That is 1 hour and 36 minutes, which is 1 3/5 hours, 8/5 hours. Now they were paddling at a rate which would have been in still water 4 miles per hour, but they were slowed by the current against them of 1.5 miles per hour. So we will subtract to get their actual speed. 4 minus 1.5 is 2.5. So they were actually accomplishing 2.5 miles per hour. So I multiply 8/5 hours times 2.5, which is 5/2 miles per hour, and I get the distance 4 miles. That means they were 4 miles from camp when they met the bottle. Now the bottle was being carried along by the current having a rate of 1.5 miles per hour. The bottle had 4 miles to go to reach the camp. We divide 4 miles by 1.5 miles per hour to get the length of time that it would take the bottle to reach the camp. 4 divided by 1.5 is 4 divided by 3/2, which is 4 times the reciprocal of 3/2, 2/3, which is 8/3 hours. That is 2 2/3 hours. So that is the time from when the campers met the bottle to when both the campers and the bottle reached camp. 2 2/3 hours. Now I am going to make a distance rate time table about the campers going upstream and then going downstream. The formula is distance equals rate times time. I will call their distance going downstream, which is the total distance from where they turned around to the camp. I will call that distance D. Their distance going upstream from where they met the bottle to where they turned around is 4 miles less than that. We established that 4 miles to begin with. So that distance is D minus 4. Their rate going upstream was 4 miles an hour, that would have been in still water, minus the rate of the current, 1.5 miles per hour. 4 minus 1.5 is 2.5, or 5/2 miles per hour. That's their upstream rate. Their downstream rate is gotten by adding those two rates, 4 miles per hour in still water plus 1.5 miles per hour, the rate of the stream. That's 5.5 miles per hour, which is 11/2 miles per hour. I will call their time going upstream from where they met the bottle to where they turned around, T. Their total time upstream from bottle to turn and turn back to camp, their total time was this 2 2/3 hours, namely the time that it took the bottle to float down to the camp. That's 8/3 hours as their total time. Therefore, their downstream time was 8/3 minus T. So now from this table we have the makings of two equations. We have the upstream equation, D minus 4 equals 5/2 T, and the downstream equation, D equals 11/2 times 8/3 minus T. There are a bunch of ways to solve this system of two equations. What I'm doing here is I'm adding 4 to both sides of this first equation, which gives me D equals 5/2 T plus 4. Since D equals this, and D also equals this, the right side of this equation, equals the right side of this equation. That gives me this equation. To get the right side here, I have distributed 11/2 times 8/3 minus T, giving me 44/3 minus 11/2 T. I multiply both sides of this equation by 6, and I get 15T plus 24 equals 88 minus 33T. I add 33T to both sides and subtract 24 from both sides, which gives me 48T equals 64. I divide both sides by 48. I get T equals 64 over 48, which reduces to 4/3 hours. I can now substitute that value into one of the early equations. I choose this one. D equals 11/2 times 8/3 minus 4/3. That's 11/2 times 4/3, which is 22/3, which is 7 1/3 miles. And that is the answer. That is the distance that the campers went upstream away from their camp before they turned around and headed back to camp. So that is my solution to my campers and bottle challenge. Thank you for watching this solution video.